So you will see these main functional groups in organic chemistry. So this is just a recap of all of this. So if we use these main functional groups, we can try to identify a few of these here. So double bond, this is alkene. You can see COOC. So COOC, we have this here. This is the ester group. So this is the ester functional group. You have, so R group, and then O in the middle. So R group and R group joined by O. This is ether. You have NH2. NH2, we can identify it here. So this is amine. And you have CO and then NH. So this is the R group over here. So the R group could be any big chain. So NH with CO here. So this is amide. So we have been able to identify those functional groups labeled. Let's try to do the same thing for the molecule of zanamivir. So we have the double bond here again. So this is again alkene. You have NH2 here. NH2, if we look for it, NH2 you identify it as amine. You have CO and H. When you have CO and H, it's not amine, it's amide. So amide is here. We have an OH here. OH, this is alcohol. And we can see again here you have the OO linking two R groups. So this is ether. And then you have COOH. This is a carboxylic acid. So COOH. This is carboxylic acid. So you can use the list over here for now to identify any main functional groups in molecules given to you. Now, both of these molecules, if we look at them, both of these molecules, Tamiflu and zanamivir, here they have a 6-membered ring with 3 chiral carbon atoms. So chiral carbon atoms here, so these are the chiral carbon atoms in the 6-membered ring. Chiral carbon atoms are carbon atoms that are bonded to 4 different substituents. So you have, let's say, R1, R2, R3, R4, or anything. So not necessarily R groups. It could be bonded to anything, as long as it's 4 different substituents. Right? So if you look at this carbon over here, this one, so you have a carbon. This is one R chain, so R1. This is the second R2. This is NH, and then let's consider this as R, so NHR, and then it's also bonded to H. So you can see that this carbon is bonded to 4 different things. So it branches to 4 different things. So because it's 4 different things, it's called a chiral carbon. Right? So there's 1, 2, 3 chiral carbon atoms. The side chains of the 2 molecules have different functional group, which affect the properties of the molecules. So you can see here, this is an ester side chain here. and here you have a carboxylic side chain, right? So in acyltamivir, you can see this is the ester side chain. In this form, acyltamivir, in its original form, it's inactive, but inside the body, this ester side chain is going to be hydrolyzed and is going to form the carboxylic acid group. And this form of acyltamivir with the carboxylic acid group, this is the active version of the antiviral drug. But if you look at zanamivir, it already has a carboxylic acid, so it's already in the active form. So acyltamivir, when it's in the original form, it's inactive, but in the body it becomes active by the carboxylic acid group. So ester will form carboxylic acid. As mentioned already, zanamivir is already in its active form, while acyltamivir becomes active inside the body, which means that acyltamivir can be taken orally because its bioavailability is not affected by this method of administration. So it's inactive when you take it, and then inside the body it becomes active. So it's not, the bioavailability is not affected. But zanamivir is already in its active form. So if you take it, the amount of drug delivered to the cells is going to be reduced. So zanamivir is taken by inhalation due to its low bioavailability when taken orally.